Slope, slope-intercept, and point slope. Uh, Reminder about slope. Slope is rise over run. Often you'll hear it say in mathematics that slope is delta y over delta x. The triangle is the Greek letter delta. And we use delta to mean change in. So when we say delta y over delta x, it means the change in y, that's the rise, over the change in x, that's the run. Look at this graph I have here as an example. I want you to understand where the formula comes from. Notice how I picked 2 points on a line. You can use any 2 points. The points are 6, 4 and 2, 1. And that all I needed to do was subtract the 4 and the 1, to get 3. That's the distance, 1, 2, 3. And down on the horizontal for the x, I took and subtracted the x's, the 6 and the 2, 6 minus 2, and that gives us 4. Instead of 4 minus 1, we can call these points x2, y2. Instead of 2 and 1, we call these points x1, y1. By the way, subscript like that, when I say x1, x2, x3, those are all just different variables, like a, b, and c are different variables. It's just that that gives us the power to have an infinite number of variables with one letter. So we've got these general points up here, an x and a y, and instead of a 4, I can use the y2, and instead of a 1, I can use the y1. So 4 minus 1 was just y2 minus y1. In other words, I subtract the y's to get the 3. And instead of 6 minus 2, I can go up above the 6, I have an x2, and above the 2, I have an x1, and I can say x1 minus x2 minus x1. And again, what this really means when I write the formula down for slope, y2 minus y1 over x2 minus x1, is that up top I subtract the y's to get the rise, and down below I subtract the x's to get the run. By the way, a really common mistake students make with this is they'll put the x's on top when they find the slope. But hang on a sec here, x is horizontal, x is left, and x is right. That's the run. Y is vertical, it's up and down. That's the rise. You have to put the y on top to get the rise, and the x below to get the run. To use this then, if I gave you 2 points on a line, let's say those points were negative 3, 4, and 6, negative 2, all I would do is subtract the y's up top, 4 minus negative 2, and below I would subtract the x's. Now it's real important, if you start with the 4, you must start with the same point below. Otherwise you'll end up with the opposite of what you want for slope. So start with the same point above and below. So since I started with the 4, I'm starting with the negative 3 minus the other x, 6. Well, the double negative makes a positive, so 4 minus negative 2 is 6. Negative 3 minus 6 is negative 9, and those are both divisible by 3, and normally we move the negative up top, so when we divide that by 3, we get 2 over negative 2 over 3. Now, by the way, I just want to point this out. You can start with either point in the top and bottom of the fraction. I could have started with the 6, 2 if I'd wanted, the 6, negative 2. So I'd subtract the y's up top, negative 2 minus 4, the other y, and down below I subtract the x's. So start with the same point. Since I started with the negative 2, it'd be 6 minus negative 3. That ends up being negative 6 over 9. 6 minus negative 3 is 6 plus 3. And again, that reduces to negative 2/3. All that's important here is that you start with the same point above and below when you find the slope. In a previous video, we talked about slope-intercept form. Quick reminder, that's when y is by itself It's y equals mx plus b, where m is the slope, that's the rise over the run, and b is the y-intercept, where the line crosses the y-axis. If I give you an example like y equal negative 3x plus 5, that means the slope is negative 3 over positive 1. We always put a number over positive 1 if there's no number there for slope, and that's the rise and that's the run. And the intercept then is 5. Another equation, y equal 2/3 x minus 4. The slope is 2/3. So every time I move from a point to a point, I go up 2 over 3. Up 2 over 3. 3 to the right. Both are positive. And our y-intercept is negative 4. Now keep in mind that's 0 and negative 4. Notice that if I take and plug in 0 for x, that it's 2/3 times 0, and y would be negative 4. Today, we're going to talk about point slope. Point slope is a formula that's used to create equations. And where it comes from is the slope formula, the formula we just talked about. y2 minus y1 over x2 minus x1. If we put the m over 1, and you might remember that thing called cross multiplication, and we cross multiplied, 1 times y2 minus y1 would be y2 minus y1. M times x2 minus x1 is what's on the other side. And this equation right here is an equation we can use to create equations given a point and a slope. That's why it's called point slope. In order to make this a little more useful, we need a normal variable in there. We need a normal x and a normal y that I can plug points into that work in the equation, that are solutions to the equation. For my normal x, y variable, I could either choose the point y1, x1 or y2, x2. And they chose y2 and x2 when they created the formula. And we're going to call those just normal variables, so they could be any point that works in the equation. Y minus y1 equals m times x minus x1. And that is the formula known as point slope. And now I'm going to show you how to use it. A key thing to understand about point slope is that you need a point and a slope to use it. You must have a point and a slope. So there are two situations you'll get into. Sometimes you'll get a point, like say negative 6, 2, and a slope, m equals 1/2, and you'll just plug it in. It'll be y minus the y of the point is 2, equals m is 1/2, times x minus the x of the point, and the x of the point is negative 6. Now notice the double negative. This happens a lot. That's going to turn that into a positive. If they ask for point slope form, this equation would be your answer. This is in point slope form. Y minus y1 equals m times x minus x1. But typically what they will do is they will ask you to put it in slope-intercept form. So then you have to remember it's y equals mx plus b. What we will do with our equation then is solve for y. Get y by itself. So y minus 2 equals, and we distribute the 1/2 to both. That would be 1/2 x plus 3. 1/2 times 6 is 3, and then we would add 2 to both sides, and that would be y equal 1/2 x plus 5. So our m, our rise over run, is positive 1 over positive 2, and our b, our y-intercept, is 0, 5. The second case for using point slope is if we're given 2 points. So if we were given points like 6, negative 4, and negative 8, comma, negative 2, the issue would be we need a point and a slope. We have 2 points. That means we need to get the slope. And we know that slope is y2 minus y1 over x2 minus x1. So we subtract the y's up top. That's -4 minus -2. Notice the double negative over 6 minus -8. Notice how the minus, the subtraction, is separate from the sign on the number. Now those are both going to be addition, so that would be -2 over 14, which reduces, simplifies to -1 over 7. Now we could use either point. So we could go y minus -4 equals, that's this one, -1/7 times x minus 6, and that would be okay. That would be one possibility, and the double negative is going to make a positive. Or we could say y minus -2 equals -1/7 times x minus -8. And those double negatives are going to make positives. So these are both correct answers. And if you put them in slope-intercept form, you'll see they're the same equation. Let's try that. Y plus 4 equals -1/7 x. I'm distributing. A -1/7 times a -6 would be a positive 6/7. Then to get y by itself, I would subtract 4 from both sides. And I'll take my calculator and take 6/7 minus 4. And I get -22/7. Y equals -1/7 x minus 22/7. So there's my m, -1/7, and there's my b, -22/7. So let's take this other equation and do the same thing. We'll solve for y. Get y by itself. Y plus 2 equals -1/7 x. -1/7 times 8 would be a -8/7. And then we'll get y by itself, subtract 2 from both sides, and we'll go to our calculator. -8/7 minus 2, and that is again -22/7. Y equal -1/7 x minus 22/7. Both these equations are equivalent in point-slope form, even though they don't look the same, because 6, -4, and -8, -2 are points on the line. They are solutions for x and y. They end up creating the same equation. Here's some questions from your assignment. In questions 1, 2, and 3, you're supposed to find the slope. To find the slope, the normal process is to pick 2 points on the line. Any 2 at all will work, and count the rise over the run. Well, what you'll notice here is that between those 2 points, the rise is 0. And between those 2 points, the run is 5. So any 2 points I pick, I'll get a run, but the rise will always be 0. And 0 divided by anything is 0. The slope of a flat line is 0. I always tell my kids, hey, remember, it's like the floor. It's horizontal. And the floor has a lot of zeros in it. So remember that the slope of a horizontal line is 0. For this second one below, I'll pick 2 points, and you can count either direction. When I pick 2 points on the line, notice I pick grid intersections, and I make a triangle, like so, and I count the rise. 1, 2, 3, 4, 5, 6, 7, 8. It's 8. 1, 2, 3, 4. It's 4. And so the rise over the run, the slope, is 8 over 4. And 8 over 4 simplifies to 2. 2 over 1. However, I've made a mistake here. Now the thing, and this is really common with students, you have to keep in mind your directions. Remember that if you go up, it's positive. Down is negative. And if I go right, like the x-axis, it's positive. And if I go left, it's negative. So you have to keep that in mind. So let's go back to that top point there. I went down 8, that's -8, and over to the right 4, that's +4. So it was -8 over 4, which gave me a slope of -2. This is one of the most common mistakes. Now I want you to understand something. I'll switch colors here. That I could have made the triangle like this if you'd wanted. And the difference would have been if I started down here and went up, that would be +8. But then when I went left, that would be -4. And the slope would have been 8 over -4. Well, the thing to observe there is both of those make a fraction of -2. For the last example here, a vertical line, again, the process is to pick 2 points on the line, any 2 points you want, and count the rise and count the run. So the rise is 1, 2, 3, 4, 5, 6, and the run is 0. And you have to remember that you can't divide by 0. That is undefined. And in WMAP terms, they will have you do DNE. Now that's not really a mathematical thing, but it's shorthand for does not exist. That's what they're using to mean undefined. Another thing to point out, students get confused with the idea of undefined and 0. They're completely different things. 0 is a slope. It's flat horizontal. It is a slope. A vertical line does not have a slope. It is undefined slope. They're totally different. Notice in these next two, the purpose of the question is for you to write the equation. As you do that, you just need to keep in mind y = mx plus b. And so pick 2 points on the line. They need to be points you can easily identify, like this one and this one would work. And count the rise and the run. So I'm going down 1, 2, 3, -3, and I'm going right. That's +2. Our equation then is y = mx plus b. -3 rise over run, -3 halves x, plus b, and b is our y-intercept, +2. For this next example, again, pick 2 points on the line. How about that one and that one? And this time out for variety, I'll count up, +1, and left. Now when you go left, that's negative, so it's -2. And our equation then is y = rise over run. That's 1 over -2. Normally you put the negative up top or out in front. -1/2 x, and then our b, our y-intercept, is right there. It crosses at 3. This one, you're just finding the slope. The slope is subtract the y's up top, -3 minus -7, and subtract the x's below. Now since I started with the -3, I must start with the same point below, 8 minus 4. And that would be -3 plus 7, which is 4, over 8 minus 4, which is 4. That gives us a slope of 1. 1 is our answer. Skipping to question 15, we're going to write an equation in slope-intercept form that has a slope of -2 and a y-intercept of -3. Now remember, the y-intercept is your b. In other words, this is the point 0b, where b is the y-intercept. So our y-intercept is -3. So this equation would be y = mx plus b, -2x minus 3. That was a quick one. For the next example, you're going to put that equation in slope-intercept form. That means you're going to get y by itself. So we'll take the equation 7x plus 8y equals -15, and we'll get y by itself. Take a 7x off each side, and we get 8y equals -7x minus 15. Now we divide everything by 8. Now these aren't exactly friendly numbers, but we get y equal -7/8x minus 15/8. So our slope is -7/8, and our y-intercept is -15/8. Find the point-slope form of a line that passes through the points 5, 4, and -9, -7. So this is like the example I did where we have to find the slope first. So 4 minus negative 7 over, subtract the x's below, 5 minus negative 9. That would be 11 over 14 because the double negative makes a positive and you add. So pick a point. How about 5, 4? I like 5, 4. Either one should work. This is y minus 4 equals 11 fourteenths times x minus 5. Now, we're going to want to use a calculator here because we're going to have to distribute 11 fourteenths. That's not real friendly. Y minus 4 equals 11 fourteenths x minus 55 fourteenths. And we'll add 4 to both sides to get y by itself. Going to the calculator, negative 55 fourteenths plus 4 is 1 14th. So it's y equal 11 fourteenths x plus 1 14th. Another question using point slope form. Remember that it is y minus y1 equals m times x minus x1. So we're supposed to use both points. This one will be y minus the 4 is the y equals the slope. Well, we need to find the slope. So let's go down here and find the slope. We'll subtract the y's up top. That's 4 minus negative 6. We'll subtract the x's below. Negative 3 minus negative 5. And we get 10 over 2, which is 5. So y minus 4 equals the slope 5 times x minus the x of the point, which is negative 3. So it'll be minus negative 3, which ends up being plus 3. For the other one, it'll be y minus negative 6, again a double negative, so that'll be plus 6, equals 5 times x minus negative 5, again a double negative, so that'll be plus 5. Now, either one should give you the same answer. If you don't get the same answer, you did something wrong. If you solve for y, you should get the same equation. I'll use both just to show you that they're the same. The top one, if I distribute, would be y minus 4 equals 5x plus 15. And I'll add 4 to both sides. And I get y equals 5x plus 19. For the other equation, it would be y plus 6 equals 5x plus 25. If I distribute the 5, I take a 6 off both sides, and I get y equals 5x plus 19. Both equations produce the same result. Last two examples. The first one, we're going to create a line parallel to another line that passes through the point 9, 2. Well, what you need to know is that if they're parallel, that means they have the same slope. So the first step is to find the slope of this equation. So I'll take and solve for y. I'll take a 2x from each side, and I get 3y equals negative 2x plus 5. And then I will divide everything by 3, and I get y equals negative 2/3 x plus 5/3. So what I really needed was this. If it's going to be parallel to this line, it's going to have the same slope, and the slope is negative 2/3. The question asks for it in slope-intercept form. To build my equation, I'm going to use point slope. So this will be y minus the y, which is right there, 2, equals the parallel slope, negative 2/3, times x minus 9. Now I just need to get y by itself. Y equal mx plus b is slope-intercept form. This will be y minus 2 equals negative 2/3 x plus 18/3. Now, that's 2 times 9 divided by 3. 18/3 is 6. And I'll add 2 to both sides. And I get y equals negative 2/3 x plus 8. For the problem below, we need to remember something from geometry. This was also discussed in one section in algebra. The perpendicular slope is the opposite reciprocal. So if I give you a slope, to find the perpendicular slope, you flip it and you make it the opposite. Sometimes you hear me say the perpendicular slope is the negative reciprocal, but it's the opposite reciprocal. So make it the opposite and flip it. So the first thing we have to do is, just like we did on the previous question, we have to find the slope. So let's take that equation, 2x plus 5y equals 4, and we'll subtract 2x from both sides. 5y equals negative 2x plus 4, and we'll divide everything by 5, and I get y equals negative 2/5 x plus 4/5. So our slope of the line is negative 2/5, which means the perpendicular, there's my symbol for perpendicular, the perpendicular slope, the perpendicular m, is the negative reciprocal, the opposite reciprocal. Flip it and make it the opposite. That would make it 5/2. We have everything we need, so we'll put it in PointSlope. Y minus the y of the point, negative 1, so it'll be plus 1, equals m, which is 5/2, x minus the x of the point, 8, and then we'll distribute because we're going to put it in slope-intercept form. Y plus 1 equals 5/2 x minus 5/2 times 8 would be 40/2. 40 divided by 2, which is 20. And then we'll take a 1 off each side, and our final answer then is y equals 5/2 x minus 21.